Hello, geometry and geometry honors. It is so good to finally get to talk with you guys. I'm so sorry I have been out, and I just look forward to being able to instruct this way for a little bit until I'm able to return. So I want to start with just a review of what you've covered in 15.1 and 15.2 about circles and your introduction to circles, arcs, and angles. And then the lessons that will be following will be an instructional video about section 15.3. And then we will finish with 15.4 instruction, where we'll talk about the equation of a circle. All right, let's get started with our review. All right, so if we look at all of this vocabulary of circles, let me be able to close mine. So all of our equations of circles, I want you to be able to see that, first of all, we have a chord. A chord is just a segment within a circle. Okay, so it goes from one side of the circle to the other. And you see the way that that's named. It says it's a segment. Central angle goes through the center of the circle. So the name of this circle is circle C. And the angle, the central angle, you see listed here. And then the other type of angle we talk about as our introduction to circles is an inscribed angle. It's inscribed inside a circle. So you still see that this is circle C. Circles are named by their centers. And this angle ADB is an inscribed angle. And the reason for that is its vertex lies on the circle itself. So if the vertex is on the circle, it's inscribed. If the vertex is on the center, it's a central angle. And in later lessons, we're going to learn, what if the angle is outside the circle? What are those called? All right, so if we start over here on the right side of my slide, we have three different types of arcs. We have a minor arc, a major arc, and then a semicircle. And a semicircle does create an arc, and it's half of the circle. So you're very familiar with what a semicircle is. And notice how we name a major arc, semicircle, major arc are both named the same. So it requires 3 letters to name a major arc and only 2 letters to name a minor arc. So if you look right here at this picture, how do we know this is a minor arc? Because it's 2 letters. So it goes from A, it's the arc, you see that symbol above the lettering, and it goes to B. So that's the arc AB. Okay. Notice it's inside the central angle, angle ACB. And we want to be able to know this terminology and use it well. All right, a major arc is always large, and it goes from A to D to B. And so that's how, or the reason why it has 3 letters. And then again, you see the arc symbol up above the naming here. So this is arc A, D, B. And it's just directions for you. Start at point A, go to D, go to B, always staying along the arc of the circle. And that's what we call a major arc. And then semicircle, we again said the arc of a semicircle is always 180 degrees. Know that the value of a circle is always, or the measure of a circle is always 360 degrees. And so here, the major arc, if we take the major arc and we subtract it from 360, the measure of angle ACB, central angle, is equal to its arc. Central angle is equal to its arc. And so that's something that we learn in this chapter. And so then you would understand this notation. Arc, the measure of arc ADB is 360 minus the measure of the central angle. Okay, so for example, if this arc right here was 50 degrees, then this angle is also 50 degrees. And then this arc ADB is going to be 310. All right, lastly, some notation that we want to look at over here is arc addition. So we just did that in the example I did. 310 plus 50 degrees is 360 degrees. An entire circle is 360 degrees. So arc addition postulate just tells us 2 arcs side by side. We can add them together to equal 1 bigger arc. Here we have an inscribed angle. Okay, so we've already learned that a central angle is equal to its arc. Okay, so these are equal. The arc measure and the central angle are equal. What about an inscribed angle? The relationship between an inscribed angle and its arc is half. And I always remember in my mind, what's bigger, the angle or the arc? Well, look, the arc is obviously larger. So we say the measure of the angle is half of the arc. So we cut the arc in half to get the measure of the angle. Just for some easy math, if this is a 60-degree arc, it's a minor arc, arc AB, 60 degrees, then this inscribed angle is going to be 30 degrees. Now, just to throw a little information at you here, what if I said, what if I drew in our central angle right here? What's the measure of our central angle? What's the same as the arc? So that's 60 degrees. 60 degrees. And then lastly, we get to see this combination of a semicircle. Okay, obviously AB is a semicircle. I'm sorry, is a diameter forming the semicircle ADB. Okay, so let's combine everything that we've just learned. We know that ADB is 180 degrees. Well, then that means this part of the circle is also 180 degrees. Because what is an entire circle? 360. So if arc ADB is 180, then the arc below here is also 180. Okay, now I don't have a name for that arc because we don't have another point in here. We would need another point in there for that. All right, so nonetheless, we know this top arc plus this bottom arc equals 360. Because we know a diameter completely splits a circle in half, top arc's 180, bottom arc's 180. Well, then how do we know this angle D is 90 degrees? How do we know that? Let's think about, first of all, we see that it's an actual theorem here, okay, inscribed angle of a diameter theorem. But let's make it make sense to us. What is the intercepted arc of this angle D? Well, we go to the end of this angle leg and we get right here. And we go to the end of this angle leg, segment BD, and we get right here. Well, the connection of those two endpoints along the circle is the intercepted arc. Well, didn't we just identify that that was 180 degrees? And then right here up above the inscribed angle theorem, didn't we identify that an inscribed angle, which angle D is inscribed because its vertex is on the circle, half of its intercepted arc, half of 180 is 90 degrees. And so my hope for you is that as I reviewed these different diagrams with you, that you see that they're all intertwined, understanding central angle, inscribed angle, understanding what an arc is, and then what are the specifics of the angles represented in a circle. Let me show you one more slide here. All right, so just as a little review, let me erase this for us. Okay, so let's see. There we go. Now it's going to erase it for us. Okay, so now let me ask you about this drawing over here that you see. We know that A is a central angle, and if we know arc, this would be arc CB. Another way I could write that is that's arc CB equals 110 degrees. Okay. So if this right here is 110 degrees, what is angle CAB right here? Central angle, so it's also 100 degrees. What about angle D? Angle CDB. Well, go to the end of its leg. There's the end point. Go to the end of the other angle leg. Well, look at that. It also intercepts arc CB. Well, if arc CB is 110, angle D is an inscribed angle. Half of 110 would be the measure of angle CDB. Okay, so then what about, let me change my color here. what about angle E? Let's notice something. Go to the end of the leg of angle E, and there's its endpoint. The end of the other leg, and there's its endpoint. It intercepts the same arc. Because it intercepts the same arc, it's going to have the same measure. So both angle D and angle E are both both 55 degrees because they intercept the same arc. Half of 110 is 55, and both of those angles intercept that 110-degree arc. So here you see an example of a central angle, and you see the example of two inscribed angles that intercept the same arc. All right, lastly, I would like to review with you. Let me erase this information here, and then let's go to okay. Let's review 15.2. So 15.2 simply talked about quadrilaterals. And the two things to note with quadrilaterals is, one, if we are able to have an inscribed, there you see that word again, inscribed, notice where the vertices of the angle are located. So for a quadrilateral, okay, so for a quadrilateral, notice these vertices are on the circle. Okay, sorry, let me go back here. All right, so do you see that these vertices are on the circle? Therefore, it's an inscribed quadrilateral. Inscribed, the vertices are on the circle. Okay, so we have inscribed angles, which we already know are half of their arcs. We also have some information about an inscribed quadrilateral. What you see here is that the opposite angles are supplementary, and we know that that means 180. Okay, and so in this problem, 5a plus 7 plus 7a plus 17 equals 180, simply because of the inscribed quadrilateral theorem. If the quadrilateral is inscribed in a circle, okay, let's make sure we know what that means. This is not inscribed because the vertices are not on the circle. If it's an inscribed quadrilateral, then we know this is true. Okay. Secondly, if the opposite angles of a quadrilateral are supplementary, then we know the quadrilateral can be inscribed. And that type of problem you would have if you didn't see a diagram. So you would be given angle measures and you would be asked, could this quadrilateral be inscribed in a circle? And the answer would be yes, if the opposite angles are supplementary. Okay. And then lastly, chord. Remember we talked about a chord is a segment within a circle. So it goes from one side of the circle to the other, not necessarily through the middle. Okay. That diameter is a chord. It's a special type of chord because it goes through the center. All right, so here we have two chords, and notice the symbol right here. Those arcs, arc AB and arc DE, are congruent. If the arcs are congruent, then the chord length is also congruent. Let me say that again. If the arc lengths are congruent, then the chord, if the arc measures, their degrees, are congruent, then the arc lengths are also congruent. All right, I hope that's been a good review for what you've already covered, the main vocabulary in chapter 15. And I will be back for another video giving you details about the tangents and what that provides in our circles. Again, it's great to see you guys.